Good morning, all of you. Am I audible to you? Good morning, all of you. Am I audible? Yes, am I audible? Okay, thank you, Danish. So, I will start Cycloconverter now. So, please forget about the profile picture there. Okay, I will start Cycloconverter. So, cycloconverters are basically AC to AC converters. That means these converters can convert AC into AC only. So, without having. So today I am going to discuss cycloconverters. So cycloconverters. Cycloconverters are very easy because these are just like rectifiers and almost equal to AC voltage controllers only. So basically cycloconverters means these are the power converters in which the alternating voltage at supply frequency is converted directly to an alternating voltage at load frequency. That means basically we are getting frequency change in it. Okay, supply is having one type of frequency, so supply frequency, and this will be converted into some other frequency called load frequency. So generally these cycloconverters are used in traction systems. So in Germany it was used in 1930 itself. So in 1930 itself this concept was used before the times of thyristors itself. Okay. So by mercury, I mean grid connect controlled mercury arc rectifiers, when that time is there in 1930 itself they have used these type of cycloconverters for converting 50 hertz supply. So this is in Germany. So obviously in Germany is also just like in India the supply frequency is 50 hertz, and this has been converted into 16 and 2 by 3 hertz. That means what happened? So this frequency, let me take this frequency as f, and this has been converted into f by 3. So let me write f dash is equal to f by 3. So what is the advantage of this conversion, and all those things will be discussed in electric traction, that is a separate entity. Okay, and this part will be dealt in separately in utilization of electrical energy. So now our job is to find out what does it mean by cycloconverter. So here simply cycloconverter means it is a AC to AC controller, AC to AC controller, where the frequency has been changed, okay, and voltage can also be changed. For example, if you haven't frequency, how frequency can be changed? Frequency can be changed by taking the time of turning on the turning off of the thyristors in a systematic manner. Okay, then you can change the frequency. And when this voltage can be varied, if alpha equal to 0 degree, you can get the change in frequency. If alpha is at different values, you will get the change in voltage also. Okay, even though you can change the frequency also, and also you can change the voltage also by changing alpha and systematic time of turning on and turning off of the thyristor. So this is the main advantage of cycloconverter. So when compared to AC to AC controllers, what will happen? When compared to AC to AC controllers, in AC to AC controllers we can only control the voltage, but coming to cycloconverters we can control the voltage and frequency also. So this is the biggest advantage of cycloconverters. Now we will see what exactly the basic principle of operation. Yes, for this basic principle of operation we can go ahead with equivalent circuit diagram. So the equivalent circuit diagram is like this. This is a sinusoidal wave. I mean, maybe you can call it as AC voltage, and this is a diode, and here load will be there. Let me call this as AC load. So let me call it as AC load, and there is one more diode here. This is also AC supply. Like this we have positive side of things here. This is, I can call it as positive voltage. EP is called EM sin omega t. Even I have this one also, EP is equal to EM sin omega naught t, EM sin omega t. So both the voltages are same. But coming to this part, this is for the positive current, so this entire part may be my cycloconverter. This is positive group and this is negative group. Okay, this may be N only. So the current coming here is IP and the current coming from this is called IN, and this is the current I naught. Voltage E naught will be equal to plus and minus. Okay, so this is positive converter and this is negative converter. Positive and negative converter, and these two converters have to be controlled by control circuit. And this is the ER, reference sine omega t. This is a reference voltage we are going to give it. So this is the basic idea of it. Okay, now we need to give pulses. Maybe if this is the thyristor type of thing, then we need to give pulses. If I give pulses to this positive group of thyristor, I am getting voltage and current, and if I give pulses to this, I am getting negative currents. Okay, so this is the basic concept, and let us move forward to know the more about it. But before going to that, here it is based on the AC load requirement. We have to see that whether it is a rectifying action or inversion action is going on. Okay, that part I will show you. So this discussion is based on a load displacement angle. That means maybe we can call it as power factor angle. So based on this angle, power factor angle, that means the difference between voltage and current, that too in load side. That means it is I naught and E naught. So the angle between E naught and I naught, based on that we are getting these currents and voltages also. So in which operation it is apt. Okay, that we will see. So if this is my voltage and current waveform, so voltage and current, and this is for positive group of current, and this is for negative group of current. This is the voltage, and after that I will take two steps like this. This is the negative group. This is the negative group. Let me take here only. Now I want to draw only one cycle here, so you can observe clearly. So here I want to draw output voltage like this. So this is E naught, and even output current is also like this. That is, it is in phase with the output voltage I naught. So here I can say that load displacement angle phi naught is equal to 0 degree, then what will happen? So here IP, whatever I have shown, IP is exactly equal to positive voltage, I mean output voltage, and for negative voltage it is not coming. So there is no negative thing in it, because if it is negative, if the source is reverse biased, I mean negative, then the diode or thyristor involving there, actually it is diode only, so we are starting from 0, alpha equal to 0, so we can call it as diode only. So the diode will be reverse biased, so it will be, this current will be 0, like this. Okay, and coming to the in, if I want to draw in here, in positive off cycle its value is 0, and in negative off cycle its value is full, like this. So by combining these two currents only, I have drawn that I naught, you can see here. Okay, and moreover voltage also, I can see even voltage is also positive, like this, for positive group. Okay, this is for positive converter, and this is for negative converter. So this is the voltage of negative converter. So now what exactly we can draw here? Here I can write what are the things, that means from here to here, what we can call, from here to here I can call, it is called rectifying action. Okay, what exactly happens in our rectifier? Same operation happened from positive of cycle, you can see here, and this is for positive group. So in positive group it is simply having rectifying action from 0 to pi. After that what will happen? After that there is no conduction in it, so it become idle after this. Coming to negative group, first it will be idle, and later it will be inversion mode. Okay, so this is for negative group or negative converter. Okay, so these are the things what really happens with this cycloconverter. Okay, if for the load displacement of phi is equal to 0 degree, and next we can move to, the next step. I mean different, we are going to see different load displacement angles. Okay, let me go ahead with phi naught is equal to, for example, minus 60 degree. Then what will happen? If phi naught is equal to minus 60 degree, what will happen? Okay, same thing will come. So let me take the same thing only and I will explain almost. If I copy this and paste this, then only you can come to know what is the difference between these two. Copy and paste. That's all. So the difference here is E naught, here I naught is same and E naught is, we need to remove E naught. So I have taken off E naught here. So it is 60 degree ahead. So what will happen? 60 degree. So this is 0 degree. So it, E naught has to start 60 degree ahead. That means somewhere here, this is what we can call, this is 180 degree, so 60 60, so 60 degree ahead means here. So from here it has to be started and it has to end here, like this. It should be like this. This is the voltage waveform here. So now what will happen to positive group? So positive group of current is same, negative group of current is same. You can see current waveform is same, so same thing will be there for these things. Then coming to EP, what is the voltage at positive group? So for positive group, the voltage will be differing, that we will see here. So what is the difference? So difference will be like this. Same thing, whatever there from here, this point to this point, you have to draw here. Okay. So from this point, what will happen? It is like increasing, and after that it is coming, and then it will be like this. Okay. So this is positive group. That means from here to here, it will be like this. Moreover, from negative group also it is like this. So negative group, this part also we have to see. That means if you know how to draw output voltage and output current, so this is the load requirement actually. So this is the load requirement. So voltage and current are known to us. If you give this phi naught and if you keep I naught as constant, so this voltage requirement is fixed, and based on that, this is positive group, kindly take the positive waveform. This is negative group, so take the negative waveform. So here also positive voltage and negative voltage. So this is En, negative voltage. So how to draw the negative voltage? So it is from this point to like this. Same thing, whatever we are getting here, so same thing we are obtaining here also. Okay, that's all. Now coming to this part, now tell me what will happen to this. What will happen to this? Okay, these parts are very important parts now, and of course very simple parts also, so nothing to worry. So let me draw these lines properly. Above one is positive group and below one is the negative group. So what exactly happens? So whenever the voltage is positive in nature up to this point, then I can say that this is rectifying. Whenever voltage is negative, I can say that this is inversion. Okay, even same thing happens here also. As this is negative in nature, so it is called inversion. As this is positive in nature, it is called rectifying. Okay, so coming to the next part, it is simply idle. So here also this part is idle up to this one. After that, what will happen? You tell me. This is the negative in nature. So negative means, for negative it is negative. So obviously it is called rectifying. Sorry, here also it is rectifying only, not the inversion. Okay, because in negative of cycle it is giving negative thing. So this is called rectifying only. So here also negative side negative is giving, so it is rectifying. Negative side positive is giving, so it is inversion. Okay, so this is for phi naught is equal to minus 60 degree. Now coming to plus 60 degree. So what will happen if it is plus 60 degree? Okay, so let me draw now. You just observe. Same thing I want to draw once again, so that you can get more idea on it. So same thing I want to draw, phi naught is equal to plus 60 degree. So first I want to draw the current. Okay, so this is the current. So this is the current. Let me take, this is 60, 120 and 180. So it is 60 degree ahead. So plus 60 degrees, so it should be right side. 1, 2, 3. So it is coming like this. Something like this it is coming, and this is current. Okay, this is voltage, no, E naught, and this is current I naught. So now I want to draw current IP in positive group. It should be like this. So for positive group, negative cycle is not at all coming, so it will be 0. And for negative group, positive group is not coming, so this is IN. Now how to draw this? Same thing from here, maybe it is from here like this. So now it is like this, like this, like this. Okay, this is EP. Negative thing is not there, and I want to write something here. Coming to this part, so how this will be negative 1? This is from positive side. See, from here onwards I need to draw. So from there onwards, it is like this. Okay, so this is called En. So now what will happen to positive group and negative group? Now tell me, as this is positive in nature, so whatever is there in the negative side, up to that part you have to write inversion. So positive side, positive signal, so this is rectifying, and after that it is 0, so it is ideal now. Okay, so this is the thing. So initially for negative, first half cycle is ideal. After that the voltage is coming positive, so positive means negative thing coming in positive, so it is inversion. Negative thing coming in negative is rectifying. Very simple concept. Okay, this is for phi naught equal to plus 60 degree. Okay, and one more thing is also there, that is for phi not equal to 180 degree. So for this one everything will be inversion only. Okay, completely reversed. Okay, it is coming completely reversed thing, so only inversion will be there, there is no rectifying. Okay, so instead of wasting much time, I would like to go ahead with the cycloconverter with resistive load. Yeah, so cycloconverter with resistive load, so it is with center tap transformer configuration also. So first one is center tap transformer configuration. So how this will be? So the circuit diagram for this one is, circuit diagram is like this. This is positive group, and from here it is load. So output is AC, so it is AC load, and here it is again the same structure. It's coming like this. That's all. So this is single phase AC 50 Hz supply, and it is positive and negative. So this is just like center tapped transformer only. I mean center tapped full wave rectifier type of thing. Okay, so the above one is P1 and below one is N1. Here above one is P2 and below one is N2. So the circuit diagram is like this. I mean waveform is coming to be 1 cycle, second cycle, third cycle, like this. Third cycle. Now I can go ahead with so let me take the input only for my clarity. Okay, this is input only. You can see that this is the input, and now how to find the output. For example, I am maintaining alpha as the angle. So just like rectifier, so whenever we are giving, this is positive group EP and this is negative NEN. So whenever we are giving any whenever positive off cycle has been given to this, so this is bigger P and this is Q. So if P is positive compared to N, Q, so plus and minus, so what will happen? P1 can be on and the current flowing is like this. That's all. Okay, P1 will be on, current flowing will be like this, and they may be alpha is the firing angle. So at alpha degree E, what will happen? This is following the voltage. And what will happen in negative off cycle? So negative off cycle means this will be positive and this will be negative. So if we give gating pulses to P2, so it will be on and it is coming like this. The current path will be like this and it is going up. Understood? So this is plus and minus V naught or E naught. So that's why it is positive only. Again, same thing repeats for positive off cycle and it will be positive. Okay. Now, if I want to get the negative pulse here, how to get it? If this is positive, and this is negative, if this is positive and this is negative, how can I get it? So if this is positive and this is negative, so this can be given to sorry, actually here if you see, input voltage is negative in nature here, negative off cycle, input voltage is negative off cycle, so this part I have to see minus and plus. If this is the case, previously we have given the supply, we have given the gating pulses to P2. Okay, now what will happen? Instead of giving gating pulses to P2, just give the gating pulses to N1. Then how it will be? So the current will flow from starting from here, or the current from flow from here and AC source N1 and back to supply like this. If you observe this point, then it will be plus and it will be minus. So voltage will be reversed. So it will be like this. So in the next off cycle, so this is positive off cycle now. So I can see this point and this point. So in positive off cycle, P1 is forward biased and N1 is reverse biased. Now positive off cycle, P2 is reverse biased, but N2 is forward biased. You can see. So now I can give the sub gating pulses to N2, and the connection, the direction of current will be like this, from this point to this point to N2 and back to this point. So now again it is minus and plus. Okay. So now again it will be like this. And next one is also same to same. What exactly happened here? Like this, it is a single phase voltage will be coming, average. Okay, average will be like this. So if this is the case, see, this is my time period t from here to here. Now this is my t dash complete. What will happen? Now I can see t dash is equal to 3 times t, 3 times t. Now what happened to f dash? F dash is equal to f by 3. So if for example f is 50 hertz, so what will happen to f dash? It will be equal to 16 and 2 by 3 hertz. Okay, and by doing this one, we are getting some harmonics. So it is better to do only for 3 cycles. Okay, if you go beyond that, you will get more and more harmonics. So with this we can handle the harmonics in a fruitful manner. Okay, so you can draw these diagrams for the examination. So this is sufficient. So this is input voltage Vs or Es, and this is E naught or V naught. So this is called center tapped transformer configuration. Similarly, RL load is also there. So if RL load is there, simple, it will go up to some level like this. It may not be sufficient up to this, then it will come like this. Simple, nothing wrong. Every time. So this is just like how we have dealt in rectifiers only, not more than that. Come here, go there. Come here, go there. Like this. Simple. Okay, very simple. So based on alpha, that will be increased. When coming to current, the current will be like this. So in each step it is increasing some current. It will be like this, like this, like this, and after that it is going to decrease, and again this, like this, like this, and like this. So finally it is looking like a sinusoidal wave. So rectifiers also, I mean, in bridge configuration also, just like rectifiers only, how we are dealing with the rectifiers, in the similar manner we need to go ahead with the bridge configuration also. So let me move forward to bridge configuration. We will see how it will be. So in rectifiers it will be like this. Load will be here. So this is the simple rectifier. So thyristors will be here. This is AC supply. That's all. This is the rectifier. Now how to show it as a cycloconverter? So anti-parallel diodes will be here. anti-parallel thyristors. So wherever we require, we will go ahead with this. This is also AC supply. So both the supplies are same only, and we are giving like this, and these are positive groups P1, P2. Let me take it. Then it should be N1, N2. If it is P3, P2, then it should be N3, N2. That's all. Very simple. Okay, so this is called bridge configuration. Okay, so these are the simple cycloconverters. Now this is for up to this it is single phase. Now there are three phase cycloconverters also. So three phase to single phase and three phase to three phase cycloconverters. So these things we will discuss in the next video. Okay. So thank you so much for your careful listening. So if you have any doubts, you can put it in the comment window, and I will close the session here. So if you have doubts, put it in the comment window, and later we will discuss. Thank you. Thank you so much.